All right, welcome back, everyone. We are on to the fifth lesson in Unit 3. We're going to continue to write equations, now just moving through the next set of functions. So we're working with absolute value here. Our standards is that I can write the equation of an absolute value function from a table of values. We've actually done a little bit of this in the first lesson. And then standard 7.2, I can write the equation of an absolute value function given information from various contexts. So the first thing I want you to do is let's think back to what we did last time. Go ahead and hit pause and work through the opener. We're going to find the slope between the two given points. Okay, so find slope. And then write an equation that has a line both parallel and perpendicular. Those lines do not have to go through a specific point, so you can choose whichever point they go through. Focus on the slopes there. Right, go ahead and hit pause, work through that. Come right back and I'll explain them real quick. All right, here's how the warm-up should have gone. Starting with the slopes of each, here in A, I went ahead and put the 2 points in a table. That way I can find the change in y divided by change in x, just using some of the habits we built with all of our table work. Then taking change in y divided by change in x of 8 divided by 4 to get 2. I went ahead and put 2 over 1 so that we have a fraction. That way it makes it easier to flip when I get to the perpendicular slope. And then for an equation of a parallel line, it did not matter. I just randomly chose the starting point of this would be -7. Remember to switch the x coordinate, comma -3 for y, and just keeping the slope the same, right? So that was the big idea there. For the perpendicular line, I went ahead and flipped the slope, so now it's 1/2. And since it started out as positive, I went ahead and made it negative. And then again, just making it something that is different than any point we started with. So passing through the y-intercept of 23. Right, similar process for B. I went ahead and used the slope formula here rather than table work. So taking y1 minus y2, dividing it by x1 minus x2, works out to be -1, which again, I made it a fraction by putting it over 1. But then when I put it in equations, I didn't go ahead and do that. I just left it as simplified. Remember, it really doesn't matter as long as it represents the same value. So equation of a parallel line, keeping the slope the same of -1, choosing any point to pass through. And then perpendicular, remember if we flip 1 divided by 1, it's still 1 divided by 1. But now I just want to make it positive. So it's y equals 1x. And then I said plus 44. You could have had something different depending on the point you chose. All right, well, let's go ahead and look at absolute value tables. We'll go ahead and do a couple of the things here. And the first thing we want to do is just resort back to what are our habits, right? Let's pretend like we have no idea this is absolute value. So let's make sure that we see this absolute value pattern and then think about how we can write the equation. So anytime we see a table, by now we should draw arrows, right? That's a habit of ours. And then finding all the change in y's over here on the right. Subtracting 3, subtracting 3, subtracting 3. Oh, all of a sudden I'm adding 3. Well, on the x's, I'm adding 1, adding 1, adding 1, adding 1. Always want to write it, even though if we see that. So when I'm working with this, I'm like, what do I notice? Well, in the change in y's, the numbers are always 3, right? But I'm switching from subtracting to adding, suggesting that the rate of change is constant, right? It's either plus or minus 3. We can also write it as plus minus 3. And the vertex or turning point is right where we switch from -3 to 3, right? So I'm going to circle 2, 6, but I want to make sure, do I see that symmetry? Well, I see a 9 in the y above and also in the y below. So that little bit of symmetry has made sure that I circled the correct turning point or correct vertex of 2, 6. So now we just put all this into our equation. Well, again, remember one thing we have to work on is we want to use a +3 or a -3 in the equation because we can't use both. So I'm like, you know what if I made a quick sketch? Well, 2, 6, or the vertex, right, it'd be right 2 up 1, 2, 3, 4, 5, 6. We don't even need to count those out, okay, but it kind of helps just to give us an idea of where exactly should that be. And then my next point, so if I go to the right one, I'm having to go up to 9. So I'm having to go up 9. Also, if I go left one, I'm going up to 9. So when I connect those, I see that this is an absolute value that opens up, and that's what tells us whether or not the a value or the slope in the equation is positive or negative. So in this case, we want it to be positive. Now, another way you could have decided that is that the equation starts off decreasing and then it starts to increase. I would be careful with that because it kind of depends on the pattern with our x values. So drawing your graph is going to be the most reliable way to truly decide what sign we want in our equation. So we're going to say y equals 3, absolute value. Remember, we do not want to use parentheses, otherwise it would be linear. Those absolute value brackets is what makes this absolute value. And now, just like we've been doing with a couple of our previous lessons, is let's take an x value and find what the y would be. So instead of x, I'm going to replace it with 9. We'll do inside the absolute value brackets first. Those behave like parentheses. I get 7. I need to take the absolute value of 7, which is still just 7, right? It did not change, but I still want to show that I'm taking the absolute value, right? Converting it to positive, because if it happened to be negative, we would absolutely need to make that change. Here, it didn't matter so much. And multiplying, 3 times 7 is 21, plus 6 is 27. All right, go ahead and flip this over. Now that you've seen me work through one, why don't you hit pause and work on number 2. After you hit unpause, I will have the all the work shown and we'll talk through it. All right. So again, hopefully you had a chance to work through this on your own, starting with finding your changes in y's and changes in x's. When we do this, I notice that my changes in x's are going up by 2 and the changes in y's are going up by 5. Now again, we want to approach these as if we have no idea what type of function. So I'm looking at this and I go, you know what? Every change in y divided by change in x is either positive 5 halves or negative 5 halves. So telling me that this is constant, and since we're switching at some point from subtracting to adding, I have a turning point or a vertex. So now giving this away that it is in fact absolute value. So the first thing I did is wrote down my change in y divided by change in x, because the rate of change is not just 5, right? We need to check what is the corresponding change in x. So it's either a plus or minus 5 halves, right? That's where I got that from. Now the vertex, where did we switch from subtracting to adding? When x was -1 and y was -5. I can again use that symmetry to make sure I've identified the right value. So I see a 0, 1 above and 1 below, and a 5, 2 above and 2 below. Now, the one thing that we need to work on is how do we again decide which sign to use in our equation? Well, let's make a sketch. And again, it doesn't need to be perfect. I don't even need to put little tick marks like I did on the last graph. I can just say, okay, where would -1, -5 be about? Be left 1 and down 5. Then if I go to +1, 0, that'd just be like right 1. I'm not going up or down at all. But I also see that I have 0 at -3, which is to the left of that vertex. So when we look at these points, we know that was the turning point. So to get to those next values, we had to go up. So telling us that the a value, or the slope in our equation, should be a positive because of the absolute value opening up. So then we have 5 halves, x plus 1, switching the sign of our x coordinate. And look at what I did. Made another common mistake of trying to go too fast. Remember, we need the absolute value brackets. If I put parentheses, this is actually linear. If we don't have our up and down brackets, those absolute value brackets, the equation is incorrect. Y coordinate, the sign stays the same. Right, let's go ahead and swap in -13. So y equals +5 halves. Absolute value of -13 plus 1. We're going to go ahead and work on the inside, doing the parentheses first. So it's -12 minus 5. This is why we always show that we're taking the absolute value, because this, the absolute value of -12, needs to turn to +12, right? That's what it means to take the absolute value, to make the number positive and measure its distance from 0. So now 5 halves times 12, well, we can go ahead and take this 5 halves, convert it to a decimal using our calculator. It's going to be 2.5. Makes it a little bit easier to multiply by 12. So I get 2.5 times 12 is 30. And minus 5 is 25. All right. So now the last set of questions will just be ones that are in various contexts. So now we're just describing different types of absolute value equations. So how can we take this information and go ahead and put it into an equation? So I'd say if you've got a pretty good understanding, why don't you hit pause and try these on your own, then just check back to see what I have. Otherwise, go ahead and just stick with me and we'll work through these real quick. So it opens up suggesting that A is positive, or slope needs to be positive. That's important. We have a slope of 1/2 and the vertex at 5, -6. So again, notice how I'm underlining things, things that are important that to kind of help me gather what type of equation, how does it all need to fit together so I write it correctly. So positive 1/2, absolute value of x, switching the sign of the x coordinate. So start as positive and the equation is negative, so -5, and the y coordinate of -6. Right, so not a whole lot to it. Shaped like a V, that's what tells us this is absolute value, right? If these were mixed with other types of descriptions, the V shape gives it away. Opens down, so A is negative. If it's shifted to the left 5, it's really talking about the vertex there. So the vertex it always starts at 0, 0 if we're graphing absolute value of x. But if it's been left 5, that means that x equals -5 of our start. And then down 3, so our y coordinate is -3, right? That's what it means to move down. And the rate of change is ±4. But remember, we're only going to use it as -4 based on the information provided. So y equals -4, absolute value of x plus 5, switching the sign, and -3. Right, the parent function, that's what I was kind of referring to in the last problem as just being the most basic absolute value equation, which is y equals absolute value of x. So its turning point is at 0, 0, and slope is 1, right? There being an invisible 1 there. And then it's reflected over the x-axis. That means that the parent function would just be a normal v-shape. And if it's been reflected, it's just going to be flipped backwards, okay, or upside down, right, coming down this x-axis. So all that does is switch the sign of the a value to be negative. There's no other description, so we don't need to write anything else. Right, opens down, meaning that a is negative, shifted to the right 30. So that means x equals 30, up 64, y is 64. And the rate of change of 5/3, but since it opens down, we're going to use the -5/3. So y equals -5/3, absolute value of x minus 30, switching the sign, and then plus 64. All right, that is all that I have for Unit 3, Lesson 5 on absolute value. Make sure you're filling out your video check-in form. Have a great rest of your day.